Today we'll solve some of the most important problems of diode circuits and analog electronics, which includes clampers, clippers, Zener diode problems, basic clippers, half-wave rectifiers, and various problems which appear in various examinations. Okay, welcome to Electronics Pariksha channel. Today we'll see the problems. Yeah, coming to the first problem, the circuit shown in the figure is a. So the circuit shown in the figure is nothing but a positive clamper. There is a capacitor, resistor R, and diode B. This is a circuit. If you observe carefully, this is the input voltage. So, during the negative half cycle of the input voltage, the diode conducts and the current flows through the diode and the capacitor. Then capacitor C charges to plus Vm. Vm is the maximum potential of the input signal. This is the Vm. During the negative half cycle, diode conducts and capacitor C charges to Vm. Now, from then onwards, from the further cycles, if you apply the output voltage, this is the output voltage, and if you consider the output voltage from the next cycle onwards, the output voltage will be plus Vm across the capacitor and V in at the input side. So the output voltage V out is equals to plus Vm plus V in. So whatever the input voltage is here, that is shifted towards the positive Vm side, shifted by the base, positive Vm, that is plus Vm. So the input voltage, the input waveform is like this. This is the input signal of plus Vm peak to peak voltage and minus Vm negative peak voltage. This will be in the output side. This will be shifted towards plus Vm. The base is shifted towards plus Vm. This is very important. Here the base is 0 for the input. The base is 0 volts. This base is shifted to plus Vm because of capacitor action. Here because of capacitor. So the output waveform will be Vm plus Vm 2Vm, Vm minus Vm 0. Vm plus Vm 2Vm and Vm minus Vm 0. It will be like this. So the peak voltage of output waveform is 2Vm. Minimum voltage is 0. This is nothing but a positive clamper because it is shifting the waveform towards the positive side. Similarly, if you see the negative clamper, same capacitor will be there, resistor R, and the diode will be facing downward direction. If the diode is facing downward direction, it is negative clamper. If the diode is facing upward direction, it is positive clamper. This is V input and this is V output. Here, during the positive half cycle, the diode conducts through the capacitor. So capacitor will be charged to minus Vm. Looking from the output side, it is minus Vm. So from the further cycles onwards, the output voltage, if you apply KVL in this direction, KVL, Kirchhoff voltage law, if you look at this, it is minus Vm plus V in. The output voltage is minus Vm plus V in. This minus Vm is nothing but the voltage across capacitor. Voltage across capacitor. So for this case, what will be the output voltage? There is an input voltage, sinusoidal signal, with positive peak plus Vm and negative peak minus Vm. Positive peak plus Vm and negative peak minus Vm. The output voltage will be here for the input voltage, the base is 0 volts. The base is 0 volts. But for the output waveform, the base is minus Vm, which is the voltage across capacitor. This is the voltage across capacitor. Minus Vm is the base. So the output waveform will be like this. Minus Vm plus Vm is 0 volts. Minus Vm during the negative half cycle is minus 2 Vm. It will be like this. So it is shifting the input signal towards the negative side. So it is called as a negative clamper. This is nothing but negative clamper. So just by observing the diagram, you should be able to say whether the given circuit is positive clamper or negative clamper. So in the given circuit here, the diode is facing upward direction. So it is positive clamper. Answer is option B. We'll see the next question. Find the output voltage if V in is 5 sin 200 pi t. So if you see the given circuit, it is nothing but a basic clipper, biased clipper circuit. So here the diode is there, diode D. Negative terminal is connected to plus 2 volts. P type is connected to V in. So by simple logic, diode will be forward biased and diode will be reverse biased. It has only two functions. So if input voltage V in is greater than 2 volts, this is 5 kilo ohm resistor. If input voltage is greater than 2 volts, the diode conducts. Diode is forward biased because the P type of the diode has higher voltage than the N type. So diode acts like a short circuit in this case. So you replace the diode with short circuit. What will be the output voltage in this case? The output voltage is equal to 2 volts. If you apply KVL, the output voltage is 2 volts. So as long as the input voltage is greater than 2 volts, the output voltage will remain at 2 volts. If input voltage is less than 2 volts, input voltage is less than 2 volts, then the diode remains as open circuit. Diode remains as open circuit. So the output voltage now is, the output voltage is equal to input voltage. The output voltage will be equal to input voltage. If you apply KVL here, the output is nothing but input voltage. So let's draw the diagram. This is the input voltage, sinusoidal waveform, whose peak value is 5 volts, whose peak value is plus 5 volts and minus 5 volts. So here, if the input voltage is greater than 2 volts will come somewhere here, plus 2 volts. If the input voltage is greater than 2, it is 2 volts. Output is 2 volts. So we have to take like this. 2 volts will come somewhere here. So this particular portion, it is 2 volts. If input voltage is less than 2 volts, then output is input. So for less than 2 volts, the output is input. It remains same as input. Okay, this is 2 volts bias. So now by observing the output, this is the output waveform. So which of the following options correlate with this? It is option A. So it is 2 volts and this is minus 5 volts. I will tell you one simple logic here. You have to observe carefully. One simple logic. How to determine the output waveform with less amount of time. See, input is given here like this. This is basically what this is, a clipper, positive clipper. So during the positive, the input voltage is like this. During the positive half cycle, the diode conducts. During the negative half cycle, diode does not conduct. As long as the diode conducts, output voltage will be 0.7. Ideally, it is 0. So during the positive half cycles, it will be 0. Negative half cycles, output voltage is equal to input voltage. This is without bias, with zero bias. There is no bias voltage here, with zero bias. Okay. If you apply a bias, this is with zero bias. Zero bias. If the same circuit, if you apply a positive bias, here you have taken a positive bias. Assume VR means you are changing the reference here. Reference voltage earlier it is at 0 voltage, 0 volts. Now you are changing the reference to plus VR. So output will be like this. You are shifting the reference to plus VR here. So what happens now? The output will have some portion of the positive signal also. Output will have some portion of the positive signal also along with negative cycle. Earlier it was only negative cycle with zero bias. Now output will have some portion of the positive cycle also because you have given the reference plus VR. For the same circuit, if you give reference voltage, the bias voltage VR is negative VR. What happens for the same circuit if you have given the negative VR? Now the reference changes to negative side. This is the negative VR, minus VR. So only this portion will be available in the output. This is minus VR. So only this particular portion will be there. output will be like this. Means originally the entire negative cycle was there with zero bias. Now that negative portion also is clipped off because of negative bias voltage. Okay. Originally this is the waveform. By applying positive to this, you will get this one. Positive bias, you will get some portion of the positive half cycle also in the output. For the same diagram, if you apply the negative VR, some portion of the negative half cycle will be clipped off. So like this, you have to analyze the circuits. Just by observing the diagram, you should be able to tell what is the output waveform. This will save a lot of time in the examination. Okay. Now we'll see the next question. Like the video, share the video, and subscribe to the channel for better content and more videos. The Zener diode breakdown voltage is 2.5 volts. Find the voltage across 2 kilo ohm. Means he's asking us to find out the voltage across this 2 kilo ohm. Okay. So first we have to think, see Zener voltage is 2.5 volts. But whether Zener is in the breakdown region or acting as a open switch, we have to check. For that, we need to find out the voltage across 3 kilo ohm resistor. Voltage across 3 kilo ohm resistor needs to be found. If this 3 voltage across 3 kilo ohm resistor is greater than 2.5, then Zener diode works in breakdown region. If it is less than 2.5, it doesn't work in breakdown region. Okay, let's analyze that. What is the current I? The voltage across 3 kilo ohm resistor is nothing but the current flowing in the circuit multiplied by 3 kilo ohms. What is the current flowing in the circuit? It is 10 divided by 5 kilo ohm plus 2 kilo ohm plus 3 kilo ohm. So it is 3 volts. So voltage across 3 kilo ohm resistor is 3 volts, which is greater than Zener breakdown voltage. So Zener operates in breakdown region. So once Zener operates in breakdown region, the circuit looks like this. This is the 10 volts, and this is a resistor 5 kilo ohm, 2 kilo ohm, and this entire circuit can be replaced with 2.5 volts. So this is the new circuit because Zener is operating in breakdown region. Now he is asking us to find out the voltage across 2 kilo ohms. So voltage across 2 kilo ohms is current flowing in the circuit multiplied by 2 kilo ohms. What is the current flowing in the circuit? It is 10 minus 2.5 volts divided by 7 kilo ohms multiplied by 2 kilo ohms. Okay. Now it is the voltage across this will be approximately 2.14 volts if you solve this. So the answer is option A. Now let's see one more question. For the above given waveform as input voltage Vi to the given circuit of a clipper, maximum and minimum voltages, values of the output voltage. What are the maximum and minimum values of the output voltage? See, just now we have discussed different type of clippers. Okay. First we will see the explanation, theoretical explanation for this. And next we'll discuss the logic behind this. See, this is output voltage. See, this diode P type is connected to plus 4 volts, N type is connected to input voltage, which is a triangular waveform, which has a peak of plus 16 and a minus 16. So, if input voltage is less than 4 volts, because here P type is connected to plus 4 volt. If N type is connected to less than 4 volt, our diode conducts. The diode acts as closed switch, diode conducts, and output is equals to 4 volts. Similarly, if input voltage is greater than 4 volts, then diode acts as an open switch. Diode is reverse biased, acts as an open switch. So output voltage is nothing but input voltage. Okay. Now let's see the diagram. This is the input voltage triangular waveform whose peak value is plus 16 and this is minus 16. Okay. Normally what happens? This is nothing but a negative clipper. This is nothing but a negative clipper. So for the negative clipper, negative peaks should not be there. Only positive peaks should be there. This is the normal behavior of a clipper. Okay. This is with zero bias. With zero bias. But here you have applied the bias of plus 4 volt. So the bias will shift to plus 4 volt. This is plus 4 volt. So what will be the output waveform now? The output waveform will be like this. Above plus 4 volt, the waveform will appear, and below plus 4 volt, output is nothing but the bias voltage. So this is the new waveform. Okay. If input is less than 4 volt, diode conducts and output is plus 4 volt. So we have seen. If input falls below 4 volt, then output will be 4 volt. If input is above 4 volt, output is nothing but input. So this is the way how to do the things based on the logic that we have discussed. For the same circuit, if you see for the same circuit, just assume for the same circuit, if he has given this is input voltage, negative bias, what will happen? You tell me. This is the diode, and negative 4 volt is given, minus 4 volt. So what will be the output? The output reference will shift here, minus 4 volt. This is the input voltage, minus 4 volt. So only this portion of the circuit, only this entire portion, sorry, this entire portion will come. Positive half cycle plus part of the negative half cycle. This entire portion will be there at the output. If you apply the negative bias, so output will be like this. Output will be like this. Generally, only positive half cycles will be there, but you have taken the negative bias voltage. So part of the negative half cycle also will come up to 4 volt, minus 4 volt. Negative half cycle also will come. Okay, this is minus 4 volt and this is plus 16 volt. This is if you have taken the negative bias voltage. But here you have taken the positive bias voltage, so the reference is shifted to plus 4 volt. So the upper peak limit is plus 16, lower peak limit is plus 4 volt. Answer is option A. Hope you understood the logic behind this diagram. How to solve the various problems based on the same problem. They can twist the question like anything. They can put positive bias voltage or negative bias voltage. They can keep the positive clipper as well as negative clipper. These are the different combinations. Now we'll see the next problem. The half-wave rectifier uses a diode with a forward resistance RF. The voltage is Vm sin omega t. The load resistance is RL. The DC current is given by. So this is the half-wave rectifier. It will have only single diode. This is the input voltage Vin, and there will be the load resistance RL. So he is telling that the diode resistance is given with RF. So during the positive half cycle, diode conducts and current flows through the diode and load resistance. During the negative half cycle, there won't be any output. So this is the input voltage, positive and negative half cycles will be there. The output voltage will be only the positive half cycles. There won't be any negative half cycle. So now he is asking us to find out DC current. DC current, IDC, for the half-wave rectifier is Im by pi. What is Im? That is nothing but I maximum. So to find out Im, we have to convert this into Vm. V by R. I is nothing but V by R. This is the basic formula. So here we can write this as Vm by pi R. R means Rf plus RL because the current flows through diode as well as load resistance. So the answer is option D. We'll see the next question. Like the video, share the video, and subscribe to the channel for better content and more videos. The diode in the circuit has cut-in voltage V. Cut-in is 0 volts. Cut-in voltage is 0 volts. So the diode is ideal. Choose the option for waveform of the output voltage. So given circuit is like this. Diode is connected in series with the input supply. This is the resistor, 22 kilo ohms. Here, the bias voltage is 5 volt. Input voltage has the positive peak at 20 volts, negative peak at 5 volts. This is 20 volts. This is minus 5 volt. This is the peak. So if you analyze the circuit, if input voltage is as the N type of the diode is connected to 5 volts, P type should be greater than 5 volts for the diode to conduct. For diode D, 'to conduct', input voltage should be greater than 5 volts. Okay, so if input is greater than 5 volts, output voltage will be, what will be the output voltage? Diode conducts, current flows in the circuit. So the output voltage is nothing but input voltage. So if input voltage is less than 5 volts, diode is open circuit. Diode acts like a open circuit. Diode is reverse bias, so acts like open circuit. Output voltage is nothing but 5 volts. So this is simple. Now we'll draw the waveform for this. The output waveform, I am drawing the output waveform directly. So if input voltage is greater than 5 volts, means the positive half cycle input voltage is 20 volts. So here the diode conducts. So the output voltage is nothing but input voltage, that is 20 volts. And that 20 volts comes into the picture. So during the negative half cycle, if you see, that is minus 5 volt. Input voltage is less than 5 volt. So the output voltage will be equal to 5 volts. See, I'll draw like this. During the positive half cycle, it is 20 volts. During the negative half cycle, it is plus 5 volts. Like this. This is the output waveform. So the answer is here. What is the answer? Answer is option E.
The Raghava Academy online coaching center for the regular and backlog students dedicated to diploma and engineering courses. Semester wise and subject wise coaching is available. Contact the number 70192 46753.